travelers are returning frightening information to Voyager 1 for Earth. NASA's rocket with the longest journey is still traversing uncovered regions of the universe almost 50 years after its launch. Scientists are baffled by the shocking facts about this well-known spacecraft. It is returning to Earth because of what seems to be a breakdown. Join us as we discuss the strange information that Voyager has been exchanging back to Earth through the delicate space investigation venture. Researchers have been drawn to the study of the domain beyond the Big Bang, including what prompted Voyager 1's launch. Among other space missions, Voyager 2 was actually the first shuttle to launch from NASA's Kennedy Space Center on August 2, 1977. On September 5th of that same year, Voyager 1 was launched about 2 weeks later. But how did they change places as twins? The weight of the two probes is around 720 kilograms, about the equivalent of a small vehicle. Both were launched during a window into an extraordinary planet alignment that resulted in a slingshot effect on the shuttle's launch from one planet to another. They have, however, needed to move at different paces and in various directions. On December 15, 1977, Voyager 1 successfully overtook its identical twin along the way. From that point on, it was our go-to resource for learning about different enigmas related to space realities. The first shuttle to do so was Voyager 1 when it began its Jovian imaging mission in 1978. It was nearly 265 million kilometers away from our planet and sent a huge number of photos back to us. Voyager 1 completed an extraordinary 108-hour stretch starting in January 1979, when it took 3,750 pictures of Jupiter's rotation to produce a time-lapse video of 10 of the planet's turns. It had gone through the system of Jovian moons in February 1979, and after a month, it discovered that Jupiter is surrounded by small rings. Voyager 1 also made a unique discovery when it found two new moons named Thebe and Metis. Right moves were made to ensure that the spacecraft was prepared for its flyby of Saturn and to prevent a potential impact with Titan, one of Saturn's moons. Voyager 1 also found for additional moons during its orbit of Saturn, including Atlas, Dione, Mimas, and Enceladus. Researchers chose to stop the explorer's Planetary mission after the Saturn mission was finished and sent both Voyager 1 and Voyager to beyond our planetary group at a speed of 325 million kilometers each year. In January 1990, the new mission, previously known as the Voyager interstellar mission, began. Some of the most renowned photos in history depicting the majority of the Sun and the planets were taken by Voyager 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are regularly referred to as the Solar System Family photograph. There were 60 total Voyager 1 shots, bringing the total number of photographs taken by the spacecraft to 670. Despite the fact that Mercury and Mars couldn't be seen in the pictures because of multiple factors, the cameras on the space probe were turned off to conserve power and memory prior to reaching interstellar space. Moreover, in addition to the interstellar probes, NASA also operates Pioneer 10, New Horizons, and Pioneer 11. Before the arrival of Voyager 1, Pioneer 10, released on February 17, 1998, was the farthest spacecraft away. Voyager 1 carried on for an additional 14 years before it finally arrived in the interstellar environment on August 25, 2012. NASA did not make its probe's achievement public until 2013. By November 2018, both probes had officially left the nearby group of planets where Voyager 2 crossed the onset of the heliopause and the interstellar medium. It is thought that Voyager 1 is 22.5 billion kilometers, or 145 astronomical units, from Earth. It has continued to give us important data that no other space probe missions have been able to reveal since it entered the unseen domain beyond our planetary group. The spacecraft has spent the majority of its 45-year journey through space in good health. However, lately, scientists have discovered some odd anomalies in its performance. Voyager 1 is sending confusing signals back to Earth, giving the impression that it is uncertain of its location coordinates. However, there is a shocking turn to the problem that most researchers face. Voyager's pre-programmed safe passage mode has not sounded an alarm, even though it should if it gets derailed in space. Up until this point, its antenna, which relays information back to Earth, appears to be in great working order. However, the data it has recently been communicating is unclear. The interstellar pilgrim is functioning routinely, taking instructions from Earth and carrying them out, as well as collecting and disseminating scientific information. But the readouts from the spacecraft's attitude and control system do not precisely reflect what is occurring inside, according to a NASA official statement. What precisely is occurring on every spacecraft that is moving toward interstellar space, including Voyager 1 and 2? Each has an extraordinary 12-inch wide gold-plated disc piled high with video and audio messages as a backup in the event that an alien species discovers it. The craft includes 35 Earth sounds, 90 minutes of 115 live photographs of Western music, and good tidings from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim. These are just a few of the items on the space DVD, in addition to being kept in 55 different languages. If external forces took control of the spacecraft, they would probably be attempting to speculate based on the signals. The idea that the spaceship is currently under the control of aliens has been quickly dismissed by researchers. Voyager's ability to function is heavily dependent on the attitude and orientation control system. First, it always keeps its antenna aimed at Earth so that scientists can precisely receive information. Furthermore, it controls how engineers position the spacecraft. Monitoring the situation now, it feels that the system for controlling attitude is functioning properly, which only adds to the problem we face right now. Additionally, none of the safety features intended to shield the rocket from danger have been activated. According to Voyager 1 project manager Susan Dodd, at this point, such a mystery is not all bad in the Explorer mission. Both spacecraft are approximately 45 years old, which is a lot older than the one that was also envisioned in the mission plan. The plan acknowledges that the spacecraft's engineering group will encounter significant difficulties in resolving the problem. Due to the distance between us and Voyager 1, as well as the spacecraft's challenges, the difficulties are enormous, largely as a result of the rocket's approximately 145 billion miles from Earth. This vast distance presents a number of difficulties that the team must navigate with caution during a rescue operation, which is almost impossible in light of the current technological and strategic constraints. Voyager 1 is way out of anyone's reach for a spacecraft or mission of repair that we could realistically send. The incredible journey of the spacecraft has brought it into the most remote parts of our planetary group and beyond into interstellar space, where it continues to travel further away from us every day. Messages from Earth take nearly 21 hours to reach Voyager 1 at the speed of light to reach its current location. This means that any order or instruction sent by the engineering team requires a significant amount of time to be received by the spacecraft. This delay poses a significant challenge for ongoing maintenance and investigation. In addition, after Voyager 1 processes any response or order, the data it transmits back to Earth will take an additional 21 hours to return. This suggests that two-way communication between the spacecraft and Earth takes an average of 2 days. Such a delay makes it particularly challenging to implement practical or iterative solutions. Troubleshooting processes, which are frequently necessary when dealing with difficult technical problems, require the engineering team to carefully plan and execute each command. Anticipating different scenarios and possible outcomes that differ from missions closer to Earth, where specialists can send and receive messages quickly. The long communication delay requires a more patient and strategic approach, as each instruction needs to be carefully crafted to address the established issues without causing additional problems. Given the extended time it takes to determine whether the order has the crucial desired effect, the delay in communication also indicates that the engineering team has few chances to communicate with the spacecraft. They must respond to each sent command efficiently and precisely, with little room for error. This requires extensive testing and ensuring that commands on Earth are accurate before they are sent to Voyager 1. In addition to these strategic challenges, the spacecraft itself is over 40 years old, established in 1977. The technology on board, though cutting edge at the time, is now considered outdated by modern standards. The engineers must collaborate with hardware and systems that were designed and constructed in the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant deterioration of the spacecraft's systems. Voyager 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over a period of 45 years. These factors contribute to its deterioration and wear of components, which enhances the challenge to maintain and repair. Despite these obstacles, the engineering team is still determined to solve the ongoing problems. They are looking into various theories about what may be causing the anomalies, testing through simulations and possible solutions on Earth. This meticulous planning approach is critical, given the stakes involved. Any incorrect instruction could worsen the situation or lead to an interruption in communication with the spacecraft. The team is also utilizing Voyager 1's redundant systems. Like many other space missions, the design of Voyager 1 included backup systems to increase its resilience to failures. The engineering team may be able to use these backup systems to restore normal operations if they confirm that a specific component is failing. To summarize, the difficulties of diagnosing and fixing the issues with Voyager 1's engineering are immense. The team is utilizing their knowledge, experience, and the innate resilience of the spacecraft to address the problems. Their careful and patient approach is essential in handling the critical communication, work-related complications, and delays, utilizing a spacecraft that is extremely distant and thoroughly aged. Despite the odds, their goal is to continue the exploration and legacy of Voyager 1's discoveries in science that go far beyond the original mission boundaries. Cosmic forces may be to blame for the breakdowns. Cosmic rays altering some of the spacecraft's high-risk electrical systems. These energetic particles, which come from distant supernovae or cosmic events, travel through space at nearly the speed of light. When they collide with Voyager 1, the particles have the ability to get inside and affect internal electronic components. The more time the spacecraft spends in space, the more likely it is that cosmic rays will impact its systems over time. This phenomenon can cause anomalous irregularities like the ones currently detected in the telemetry of Voyager 1's data. Engineers have long been aware of the potential risks of cosmic rays to spacecraft devices and even human explorers, but the scope of their impact can be hard to anticipate or reduce. Despite these difficulties, engineers have used a variety of ways to protect spacecraft from cosmic rays, including shielding sensitive devices and using error-correcting codes and data transmission. Even with these safeguards, cosmic rays can still pose a danger, particularly to spacecraft in long-term operation in deep space, as in the case of Voyager 1. Although the current anomalies in the data from Voyager 1 are baffling, they are not at all surprising given the spacecraft's age and extended exposure to cosmic rays. Engineers and scientists keep an eye on the situation and analyze the data received from Voyager 1 to determine the precise reason for the anomalies and devise methods to reduce their impact on the spacecraft's operations. Despite these challenges, Voyager 1 has met far more goals than its initial mission objectives and continues to offer useful insights into the outermost regions of our planetary system. Its accomplishments provide evidence of its ingenious creators and the team's steadfastness that has supported it for over 40 years. The journey of Voyager 1 is a symbol of humankind's insatiable curiosity and determination to investigate the undiscovered. As we look toward the farthest reaches of space, Voyager 1 and future missions like it will keep motivating us and expanding our understanding of the universe.